Welcome back, PlayBASIC coders. In today's update, we'll be looking at a thing called PlayMapper Classic Loader. It's an old SLib. It's included with the product. It's the loading tool that comes with a map editor called PlayMapper, the classic one, the original one that Sin wrote. And I've sort of updated this library and the PlayUFF library that it is based upon. The test scene here is very simple, but now we've got the loader down to just one file, or one function, I should say. Open her up, world's simplest little map. Yay! Okay, so we'll have a look at it anyway. You used to have to load this twice, and that was because the PlayUFF library, which Sin wrote his own version of this years ago, and it's been included in the package ever since, and it kind of replaced I think Empty wrote a version of it too, and I wrote a version of it. UFF it's a very simple format. It's not meant to be complicated. You just have classes and variables, that's it. And you can have nested classes, and you can store data in a sort of an easily readable format. And ideally, you can do that in a way where you don't need to actually have, where different tools can access the same file and add different properties to it without having the savers having to understand the extra unknown fields to them. So the loader function itself, uses PlayUFF. The original header is still there. This says 2006. I thought it was probably earlier than that. That's very early versions of PlayBASIC there we're talking about. Probably like revision, 1.05 or something like that. Or probably the alphas actually. Standard sort of header for modern libraries, so we can enable explicit to try and catch any typo kind of problems that might be in the library. So we force the library to be explicit, and at the bottom we reset that mode back to whatever the user had it. So if you don't want explicit in your code, it doesn't make any difference. The library can use that, and you don't have to use it if you don't want to. So you can have implicit declarations wherever you want. I've made one change to it. I've renamed this function here. Given that the number of people who use this stuff, I don't really think that it's going to upset anyone. And this function has been broken up into two parts. It's pretty much this version here. You give it a map library, and inside that map has a field called profile, and the profile has all of the information about how the blocks are set up for this map. So the map contains the layers or the tile layers and basic properties like the width and height of the thing. But the profile has the common elements that are the same across all of the maps. So what block set to use, what animations are in this thing, that kind of stuff, size of your blocks, all that kind of good stuff. This used to be one big sort of monolith function, but I've broken it up into a few different parts to try and make the parts more reusable, I guess you'd call it. Here we're relying on the new functionality of the library, so we can open one of these databases. I'll show you what they are in a second, actually, in case you've forgotten. We do a request, we grab profile from it, then we unload the document straight away. So this function is kind of loading the database to get one thing from it and then throwing it away. It's a bit silly, really. And then here it's doing a load of this profile we just actually requested from the map. That does the actual PB map setup stuff. Creates the map, creates the animations, creates the blocks, and then clears all of the levels out actually, and then you're meant to call the load map function after that. What I've done now is I've added an optional parameter to tell it, hey, rather than having to preload the profile beforehand rather than call this previous function, why don't you just, when you load the map, why don't you query the map to see what the profile is, load it and decode that into the current map. I know I'm reusing the same word a lot, but and then we're all done in one call. That doesn't need to be that. Bit of debug. When this is, if this fails, it'll actually stop. That's the way it was set up originally. If this fails here, it calls the error function. Gives you an error message, a really basic error message about what happened. You know, that's really just for debugging in a live sense. So we'll try it here actually. If we pass it to something it doesn't know, soccer field 9, put a big number there or something. What do we get? It's program will now shut down. So much for our error messages working. Let's have a look at that one. It's character 10 message. Oh, there it is. We're not here. I'm actually using just a character 10 on the end there. Probably should use a pipe character or something like that, so you can have a bunch of text in is one string, split it, and then just display it. We'll try that again, see what we get. That's a bit better. PlayMapper profile not found for map. Yeah, look, it's not the best thing in the world. That's fine. Because we can have these things have multiple documents now in PlayUFF, we can load the document, and now what I had to do before was had to load that, grab the field, unload it, load a new document, then possibly reload that thing in the future. The structure of this, I haven't actually set up a way where you can just load the profiles once and then just reinitialize them when you need to. That's obviously a cleaner way of doing it. So all of this is based around this UFF library. Now, I wrote the original one, and I wrote the original version of this. I think it's back in Amos days. I think we might jump to the actual example of this. Where are we? 5.2. That's the one. Yeah. Okay, so we're actually loading that there as a bit of a test process for the whole thing. We'll open the library, of course, so you can see the code. Bit of spiel, same setup headers before. We're just trying to make sure all of these things work, feel like they're all cohesive and together. Most of these libraries have the same structure. You've got a declaration area, and then you've got your API below that. I've intentionally used the same function names that Sin used in his to try and make it function compatible with his. I did notice there was a couple of functions in his version of the library that I hadn't implemented, and they weren't really necessary. They were like a split function to split up a string into fragments. So because you can just do that inline, that was split string to an array, for example. The main difference with this version is that when you load a new document or create a new document, it has an internal index about which one you're referring to. So that becomes the current document. Think of that like drawing to an image in PB. Like you don't have to keep referring to the image all the time. Like imagine, if we just jump over here for a second to the bottom. Like those are familiar with PB. Test, whatever. So if I created an image or just went new image and 500 by 400, whatever, and give us the handle or the index of that thing. Now I redirect all rendering to my new image. Once I've done that, I don't need to refer to the image again. The commands use the current active surface for reading and writing too. That's the same principle. There's one difference, I guess, is that when we create an image or a new image in PlayBASIC, focus is not shifted to that image immediately. It's neither here nor there, but in this library, when you create something, I can get rid of that. This is garbage anyway. In this library, when you create a new database, it does shift the focus to this new thing automatically for you. So when you load one, that means the library is backward compatible with how it used to work. So I'm kind of, it's not that I don't like that. It's just like, well, that's just the way it works. Fair enough. What I'll probably do is I'll probably add a secondary library to add more exotic functions to the whole thing. At the moment, I don't really think we need them. What we've got, if we flip through the functionality a little bit, we can read properties, we can get int, get float, so we have a class and then a variable within the class, and I'll show you what that actually looks like. Where are we? Here, examples, thanks. So we'll look at this, I think the one's at the bottom here, document variables. Yeah. This document was created internally as just an empty document. My data is a class, and sprites is a child of that parent. So this is like the root, that's like the trunk, we call it. That's like the branch at the top there. Think of that as like a tree structure. So in this file, we have two different roots. We have my data and maps, which is, again, they're just junk for testing. And within maps, we have all of these variables here that equal this data here. Now, in this case here, it's just text, but it could be anything you want. But you're reading and writing it as if it was just a string. The library has no real concept of these variables being a particular type. It's not type aware, they're just a string. That's how it looks, and that's the case here. So if we go back to the example, and up here, we'll see where that wobble test is. Step through it. So we're testing variables here. We're making a new document called this thing. We make the new document. Here we've just got debug about, do we create a new document? What's the index of that thing? You don't even have to return this if you don't want to, because it becomes a current. You could create the new document, do some stuff, and then just unload it, which is just delete. Here I've got a save function. So we're talking about this one here, which is going to be an empty document. There's nothing added to it. I'm reloading the document to check if I can load an empty document. Then we're adding a class called my data. Then we're adding classes that are a parent and child, really. We could just do this like this, actually. We don't actually need to do that. So if we run it, see if it works, reload it. So here you can see we created the same structure, but we just gave it, it realized that my data didn't exist, it realized sprites didn't exist, and created collisions with just the one call. It's pretty handy. There's a delete class as well. There really should be things like rename class as well. Maybe copy class, those kind of things. So you can do a bunch of maintenance kind of stuff to these things. I think that those functions would be better off in like an extension. So if you just want to read a file quickly, you just drag in PlayUFF, point at the thing, grab the fields you want, and then life continues. Let's move on to variables. We've got our class name. So when we add variable, well, here we've got we're checking if something exists. So where's a parent? Do we have a variable called name inside my data? We don't here because we've just created these classes. So there's no variable that exists. So that would return a false. We can add the variable, give it some default data, and here the data is going to be wobble, whatever it is up here. Here I'm just printing the status of those two things. We're checking if that variable exists, and we're returning the current state of it. Now, if you do a query of something that doesn't exist as a string, it would just return zero, like an empty string for you. What is missing actually at the moment, and even from the older libraries too, is asking it about what the hierarchy is. So going, oh well, I know my data is there, but what of these classes do we have inside here? These are unique names too. So if you want to have multiple occurrences of sprites, what I would actually do is well, actually, what the mapper does as well. I just have them, sprite 1 or whatever, just index them out. But then I would have like a field, a variable, sprite range, let's call it, and it might just be two values. It might be the start and the end, or sprite range start, or something like that. 1 here. If the two things do exist, two variables exist of the same name, it will find the first occurrence of that. So when you refer to a variable, you're giving it what class to find it in. If it's, so if it's if it's in here, you might have I don't know, the title of the character, and this is like bad guy 43 or something. So we read sprite range 1, start, end, and start requesting, is there a class called sprite 1? If there is, okay. What's the title of this guy? Oh, great. Then we move to sprite 2. Does that exist? If it doesn't, fine, that's cool. So we can sort of step through this thing without really understanding it. And the best part of this is now you can have multiple documents in memory, and we don't treat the document as like it's a binary format. That's the main benefit of this approach. It's really simple. It means that there's a disconnect between how we have our data arranged. So if we're doing something like sprites, for example, like that, if you might have a sprite scene, or you might just call them characters within your game world. You might just have a list through. Okay, well, I'll have all of the characters in separate classes, and then each character we can run through and pull them out. So you might have one tool that does placement on top of the map, let's say, and that stores the sprites as sprite 1 through until whatever it's going to be, and might be type classifiers or whatever. Then you might have secondary data that's stored inside the sprite as well, from like the shape editor, for example, which might be the actual shape outline for this collision method, or it's hit, something about its pathing or character, other things to do with its movement or animation or something like that, that's unique to that character. If we load this stuff in as XML, what happens is you you often see a loader where it will run through, it streams the data from the source format, loads it into a structure. In our case, it's a type, or let's say it's, character or whatever it's going to be. And our characters, might have a title string like we just had before. We have, a position as well, position X and all that good stuff. And who knows, each different character can have all kinds of different custom properties for it, can't it? Like, you'd often use subclassing to do this. You'd often have a base type here and then inherit from other things. And, this is a dog character, that one's a cat, this one's a car, that one's a tree, or whatever it's going to be inside the world space. And they will all have different attributes as well. What you often see is these loaders would load into a predefined type, and then at the end of that, if that allows you to modify it and write it back to disk, any secondary data that's been added to each object type is lost. So we went back to this the soccer field example here. This is from PlayMapper, I don't know, 20 years ago now. Here I've deliberately added extra variables to this just to demonstrate the idea. So secondary tools can add extra data to this, but the map loader doesn't care about this. So if I read this in and then save it out from the map loader, all of these secondary variables are kept. Because the way it works is that the document's loaded into basically a string array. We make a map of where all the keys are against the document. When we're just modifying the rows of that array, that's all we're doing. If you insert something, it has to copy the array around and do that sort of awkward stuff, but that's all fine. Then when we save it, we just dump all of that stuff back to disk. So you can have you don't have to build monolith kind of tools. You can build smaller tools with like a launch pad, like something that launches your map editor, something that launches your sprite editor, something that launches your that takes the two pieces of data and builds a world from that, placing the characters around the maps together, and that data can be stored in one larger structure in here without having to separate it all out. And as you build more and more exotic objects, you can do those things with the simplest of rules. You don't need anything complicated. I mean, here the map loader is querying a variable called layers, and now it knows that we have two layers of map. We have layer 1 and layer 2. They're baked in names. When Sin made the map format, that's what he called them. Or you can have on the end of this, or the start, or whatever you wanted. It doesn't read them in order. You just query them, and then that's what you get. You can have sprites if you want. Sprites class in here, and go, well, how many sprites are there? Sprite count equals 10, and then run through and go, oh yeah, okay. SPR1 or something. Sprite 2, 3, 4. This format has kind of set rules about the structure. Classes have the angular brackets, and it looks a bit XML-ish a bit. I mean, people have complained in the past about, it's that's not the intent. The intent is not to be XML. It never was. the intent is to have this thing that can be easily passed between different things and be shared and still make sense to different applications, even when extra data is added to these things. In here, this is how I did this stuff 20 something years ago. I think the first real versions of this were written in Visual Basic, and you had a bunch of these tools for building, I think it was websites at the time, and you would make these had like a central launcher, and then, as I was saying before, you could say, oh, I want to edit the front page, and the front page editor will come up, and it was just setting the properties. Close it, go back, rerun the build process, and there you go. The static version of the site was built for you. I mean, these days, all that stuff's done in PHP or whatever. Anyway, so this gives us, reinvigorates an old idea, or makes use of this old idea better than what we had before. It's kind of an unknown thing, really. There wasn't. This stuff was pretty well unknown back in the day, and it wasn't documented either. It was known about in the early days of PlayBASIC, and it's just when it's not out there being thrust in people's faces, they won't. If you can't read it in the documentation, or if you don't pick through the old examples, you would never run into it. Yeah, I'm not going to say it's fantastic, but it serves a purpose, and that's the purpose it's trying to do. It's not trying to be these other things. It's easy. It's just dead easy. As you can see there too, you can have comments in this format too. So if you load this and save it out again, I can stick some other data in here. That would be kept. I think what would be handy is to have something that returns the classes for you, so you could sort of decipher files or run through the key list. Probably the key list is probably the simplest way of doing that. Just have some functions for running for the key list, and then reacting. Oh, this is a class. This is. I wouldn't say this is very optimal. It really is that kind of data sharing tool set sort of thing. Keep it all simple. When you're done with that, like I said this before, but when you're building your application to deploy out to people, you can have your own, baked in formats and to protect the information that you're putting out there. If it's easy to modify the characters in your game in a text editor, then anyone can run through and modify the characters. Set them all to hit point, 1 hit point or something like that, or have the score. Maybe each sprite here has like a. Well, you could have like a character class. What kind of? You might call it object class, I guess. Dog. This one here happens to be a dragon or something like that. And those object classes might be defined in the same document or in a previous document, or who knows. Because they can all be loaded in memory and used together now. They couldn't really be used like that in the past. Sorry, you might have characters, and then in characters you might have a thing in here where it's like dog. See what I'm getting at? So when you're loading sprite 1, you query object class, you get dog, and you've got the class name of the character. And that could be the same for every object there, or maybe you even wrap sprites up into something like this, where you go, well, hey, these are dogs. Yeah, whatever the structure you feel like, really. Anyway, that's probably enough for me. That's probably confusing enough for people. Long story short, we've got that library updated and ready to rock. Hasn't been tested much, but a few bits and pieces there, like delete variables not implemented. API wise, we've got set and get functions to retrieve something as, in this case here, it's as a floating point value. We probably should have an array there as well, shouldn't we? We could have more of these things here that are particularly, PB related, like it's a map layer or it's an array of strings or something like that. It's for adding classes. If you're wondering how it works for multi-document, internally we have one array. I've just typed, that's the keys, sorry. This is each document. We just have one array of these documents. So this structure holds two other arrays which we're dynamically processing all the time. So I just hide that. When we create something new, where are we? There we go. Create a new DB, standard, find me a space in the array for this stuff and allocate it. Give us the index. We manually allocate it. Store the file name. Reset the keys. That's really unnecessary, isn't it? Given that keys will be 0 anyway. We call a function to do an array allocation, dynamically return the handle, and then we keep this handle with here. So the keys are just it's the variable names and the class names that we're looking for in the document. So we're not searching through the raw text at all. We're just looking through the function names and those things, through the key names all the time. There's some provision there has been made. They've got the names are hashed, for example. So we're doing a bunch of integer comparisons to find things. And then if the hashes match, then we'll check to see if the keys match. But that's pretty much it. So this is the raw document. This is actually the string array that holds all of that. The keys array is of type keys. Key has a name, has a hash, has a class type. Is it a class or a field? And what line number does it actually equate to on the actual raw document? And that's it. What we probably should have here, actually, now I think of it, is if it's a class, we should have if it's the start of a class, we should have a link to the end of the class, so that the raw search can just skip over whole subsections or whole roots of whole trees of classes that don't relate to our current key search. But anyway, all pretty much for muchness. I think this one works a bit different than the old one. I remember trying to cache the searching, and I was more obsessed about, or I wouldn't say obsessed, but I was more trying to mitigate the searching. And this one here, I haven't really tried to do that. I think just having a list of keys makes that pretty much comfortable for it to do anyway. Anyway, dudes, gotta go. Thanks for watching, and I'll see you next time. All this stuff will end up, all this stuff will be in the next build or whatever, which will be wherever it gets shipped, probably over the weekend sometime. There's a line clipping bug. I managed to add a lovely line clipping bug I've got to fix. The joys of making stuff sometimes. Hard to believe. Alright, that's enough for me. I'll see you next time. Bye.